Okay, so we're going to go through the mock exam paper that was on C1 to C6. The grade boundaries for this were 45 out of 59 for an A star, 37 for an A, 31 for a B, 21 for a C, 13 for a D, and 9 for an E. And then you can't get below an E in higher papers. So the first question was asking about the relationship between nitrogen dioxide and the number of cars that passed a particular point each minute. The first bit that you were being asked to do here was describe, well, what is actually happening, what's the relationship here. So first describe the relationship and then explain it using your knowledge of the reactions in a car engine. So what actually is the relationship? Well, as you can see here, as the number of vehicles per minute increases, so does the nitrogen dioxide concentration. And that's why we have this positive correlation that you can see in the graph. And that actually got you about half the marks. You would have got at least 3 out of 6 for saying that. The second part was describing why is this actually happening, using your knowledge of the reactions in a car engine. So what's going on here to make the nitrogen dioxide is that nitrogen, which is in the air, is reacting with oxygen, also in the air, to form nitrogen dioxide. The reason that they're able to react in a car engine when they don't react in the normal atmosphere is because of the high temperatures. Had you said that, that would have been a full 6 marks. So I've described the relationship by saying it's a positive correlation, and I've said why this happens because of the reactions between the nitrogen and the oxygen in the engine. Just as a final note on this question, nowhere does it mention catalytic converters. You're not asked about catalytic converters, and actually any comment on it in your answer was ignored because the marks came. So then we have a question. These are quite common, these data analysis questions, especially in C1. And it's asking initially, why did scientists include all of the data when calculating the best estimate? The reason that they do this, and the reason they've done it for this one, and a lot of you saw this 132 and thought it was an outlier, but if you're being told that the scientists included them all, it is because they didn't believe that this was an outlier. They didn't think that it was an outlier. They had no reason to believe that, and that would have been enough for 2 marks. So the first mark would have been saying that there were no outliers, and the second mark was to say that there was no evidence for any outliers, and that would have got you 2 marks. Most people got 1 on that one. This next question, calculate the best estimate for nitrogen dioxide concentration. The best estimate is another way of saying the average, and most of you got that, which was great. The first part that you need to be careful of here is they actually show you're working. Because if for whatever reason you get the wrong answer, if you've shown you're working that you were trying to calculate an average, that would have got you 1 mark. A lot of you did that, but then give a wrong answer in the best estimate. You give an answer of 123.6, and that was due to incorrect rounding. When you did it in your calculator, you should have got 123.66, which actually rounds up to 123.7, and that was the correct answer. Okay, if you give that an incorrect answer, but you didn't show you're working, then you got 0 marks. If you had shown you're working, you would have got 1 mark at least. If you need to go back and look how to round numbers, make sure you do so or come and speak to one of your teachers. The scientists then take similar measurements next to a different motorway, and the question here is being asked to just explain how this motorway's nitrogen dioxide concentration is different from that measured next to the first motorway. So a lot of you just said it was a higher number. Now that is a very, very simplistic answer, especially on a chemistry paper. What you were being asked to think about here was, what is a real difference? And a real difference is when 2 sets of data do not overlap. Okay, their range bars don't overlap. So the mark here was for saying that the average in motorway 1 was outside the range of motorway 2. And that would have got you the mark there. So just keep that in mind when you're asked about 2 sets of data being different. What they're really getting at is the range bars and whether or not they overlap. So in this question you were asked for 2 ways that chemicals from refined crude oil are used, and that last point is, or that last word is the important word here. How is it used? A lot of you gave specific examples, so you would have said petrol or bitumen or diesel or plastic, but that is not saying how they are being used. It's telling you the name of the product that you're given. The uses for these things are as fuel, in the case of petrol and diesel. You can use it as a lubricating oil, or maybe as tar on roads. Okay, so you're actually saying what it's being used for. You're not just saying tar, but you're saying tar on roads, and that would have got your mark. So be careful about those little words. Then you're being asked why this process works. It's called fractional distillation. So why does this process separate the hydrocarbons into fractions? The first mark was for saying that the longer the hydrocarbon chains, the larger the forces between them. Okay, so longer chains stick together better. It's kind of like Velcro. A longer bit of Velcro is going to stick together better than little bits of Velcro. The second point was for explaining why that was the case, and it's because large molecules need more energy to vaporize them, as in turn them into a gas, compared to small molecules. Okay, because if they're stuck together better, you're going to need to put more energy in to separate them. This question was not as complicated as what some people thought it was. I think some people here just weren't sure about what they were being asked. What they were trying to get at in this question is it was telling you that you have three compounds, ethane, water, and ethanol, and you're simply being asked to show the number of atoms of each element in each of those reactants. So let's look at ethane, which is C2H4. How many carbons can you see in ethane? Well, there's 2, because it's C2. How many hydrogens? 4. And how many oxygens? 0. So it was 2, 4, 0. For water, which is H2O, how many carbons are there in water? Well, there's none. How many hydrogens? 2. How many oxygens? 1. And then in ethanol, how many carbons? Well, I have 2 carbons, C2. How many hydrogens? Well, I have 5 hydrogens here, but don't forget I've also got 1 there, so that makes a total of 6. And then I have 1 oxygen. So the last case was 2, 6, 1. That's a really common type of question, especially for 3 marks. You should have really been able to do that one without too much difficulty. Then we moved on to a question about chlorination. I think you'll find this in C3. And you're being asked describe and explain how the use of chlorine has helped to stop people in cities such as Exeter being affected by cholera. So 2 marks, so they're looking for 2 points. The first point is that cholera is caused by a bacteria. The second point was for saying that chlorine kills bacteria. Not chlorine gets rid of it, but chlorine actually kills the bacteria. So if you kill the bacteria, or the chlorine kills the bacteria, and the bacteria causes cholera, then you're getting rid of cholera. Some people talked about killing cholera, but you can't do that because it's not a living thing. It's a disease like any other thing, so you can't actually kill it. The second part then was a 6 marker asking about how pesticides can cause environmental or health problems. Some of you talked about chlorine at length, even though you're being asked about how the pesticides cause problems, and so you could be given pretty much 0 marks for that question if you just talked about chlorine. This was divided into 2 parts. You had to describe how the pesticides can contaminate the environment for the first part, and then what was the health threat. So in terms of contaminating the environment, you could say that they are toxic. The contamination can spread over long distances, and it can stay in the environment for a long time. Why is there a health threat? Well, it can kill wildlife. It can kill beneficial insects. That may go into the first section actually. But also they can bioaccumulate, so they can build up in the insects and then the animals that eat those insects, and eventually as we go up the food chain, we may be eating animals that have built up a large amount of pesticides in their bodies. We may also be eating crops that still have pesticides on them, and if those pesticides are toxic, then that can cause harm to human health. Okay, so check out the mark scheme on that for some more specific points, but you were looking for 1 point, what is the health threat that they pose, and 2, how do the pesticides actually contaminate the environment in the first place. Then you were being asked a judgment question. You were asked to evaluate the for and against for the use of DDT, which is a pesticide in countries with malaria. So you could have answered whatever way you wanted. If you said yes, we should ban it, you would have said you had to describe why that was the case. And so it would be things like the DDT causes harm to the birds, and so some species may become extinct, the food chain may be disrupted, and so on. As long as you give justification, 3 cases of justification, then you got your marks. You may have said no, because DDT stops people from getting malaria, and therefore saves lives. That would have got you a couple of marks as well. Or you could have given a balance between 2 arguments and said that humans are more important than birds, the benefits outweigh the risks. A lot of people did this and said only ban it in countries where there is no malaria or there's a low bird population, and some of you did that as well. 3 marks, so you're looking for 3 points, and that's really important that you stick with that when you come to do your actual exam. Always check how many marks is my question worth. Then part D, a neutralization reaction between an acid and an alkali. So acids, sulfuric acid, will always go to a sulfate. And so in this case, because we've got sodium hydroxide, that's going to go to sodium sulfate. And the other product in this case, which we weren't asked for, was water. Then another acid and an alkali. Again, it's sodium, but this time we're reacting with nitric acid, and that goes to nitrate. So your salt there was sodium nitrate. And that should have been a relatively easy 2 marks. Then we have a question. Some of you have seen this before, and you're being asked to give the state symbols and balance an equation for the reaction between lithium and hydrogen. So let's start with our state symbols. We're told in the question that lithium is a liquid at high temperatures and that lithium hydride is a solid. So all you had to do was a lowercase l there. If you gave uppercase, that's incorrect. Hydrogen is a gas, and lithium hydride is a solid. You're told that in the question. That was 1 mark. The other part was for balancing it, and this was done relatively well. You saw that there was 2 hydrogens here, and so I needed to put a big 2 in the front because I need 2 times of this 1 hydrogen. So that would be 2, and I've now got 2 lithiums, so I'll put a 2 there as well, and that would be my answer. So 2 L G 2 S. Okay, all lowercase. The formula for lithium hydride is LiH. What is the formula of a hydride ion? So if this is lithium hydride, then hydride must just be that H. Okay, you're told that the lithium is +1. Therefore, the H must have a minus charge. So it's not going to be 2 minus, it's going to be 1 minus, and this was the correct answer, H minus. Some people did not answer this question at all. And if it's a question like put a ring around the correct answer, you guess. Okay? If you have no clue whatsoever, you just guess, because then at least you have a chance of getting it right. You shouldn't be leaving questions like this, especially questions like this, blank. All of these other ones, you're not going to have positive charges for the last 3 because the lithium is positive. And you're not going to have this one where it's H2 minus because we only have 1 hydrogen there. We don't have H2. What is the name of this compound, CaH twice? Well, Ca is calcium. H is going to be, this is going to be 2 H minuses because Ca is Ca2 plus. And so this one was calcium hydride. Some people in this question put calcium hydroxide, but please don't forget that hydroxide is OH minus. Okay, so it couldn't have been hydroxide. This was a question answered relatively poorly for 3 marks. So Ben says that he can use these flame colours to show that there's no calcium or sodium in the mineral, and that the flame colour will not prove that the mineral contains arsenic. So you had to separate this into 2 different parts. Why is the first part true? How can he use these colours to show that there's no calcium or sodium? Well, if he doesn't see a red flame or a yellow flame, he knows that there's no calcium or sodium. And that would have got you the first mark. The second mark was for proving or for explaining why this was true. The flame colour will not prove that the mineral contains arsenic. So the 2 marks that you would have got for this part were for saying, well, if it's blue, it may be arsenic. Okay, so it could show that it's arsenic. However, copper also gives you a blue flame, and so you can't be sure which it is. And that was the second and third mark for saying it might be arsenic if it's blue. However, it could also be copper because it is blue. Okay, so always refer back to what is being said in the question. This question, again, not answered very well by a lot of people, and this is a line spectrum of arsenic. Okay, so we're not really concerned with the colours, we're concerned with the lines. Okay, so how can Ben use a line spectrum to show that the mineral contains arsenic and other elements? So let's separate it into 2 again. How can he show that it contains arsenic? Well, if the line spectrum of arsenic has the same lines as the line spectrum from the mineral, okay, if those lines match up, then there must be arsenic in there. How can we show that there are other elements? If there are extra lines in the line spectrum of the mineral, then there must be extra elements. And that was the second mark. So the first mark was if the lines match up between the line spectrum of arsenic and the line spectrum from the mineral. That's 1 mark. And for the second mark, it was for saying that if there's other lines in the line spectrum of the mineral, then there must be other elements. This question was answered very, very well. You were being asked, how does the table show that the 2 atoms are the same element? And it was because the number of protons were the same. That's what gives an element its identity, is by the number of protons that it has. You were then asked to read some information about the atmosphere on different planets, and this was a point that was missed by a few of you, using the gases named in the information. Okay, so the gases we could choose from are hydrogen, helium, nitrogen, and carbon dioxide. Some of you mentioned oxygen as one of your answers, which isn't one of these options, so please be careful with that. So start off with a gas whose molecules have a relative formula mass, an RFM, of 2. So the first thing you had to realise here was that we are talking about molecules. We're not talking about atoms. A lot of you put helium for this. Firstly, the relative formula mass of helium is 4. It's always the bigger number that you're looking for. In that case, it's 4, so it can't be helium. Also, helium does not exist as molecules. Helium is in group 8 and exists as single atoms. Okay, so it can't be that. Which leaves us with nitrogen, carbon dioxide, or hydrogen. And the answer was hydrogen. Okay, really small molecular mass. An atom of hydrogen has a mass of 1. And so because it's diatomic, as in it's H2, that gives you a mass of 2. So this was hydrogen. A gas that is a compound is a substance made of 2 or more different types of elements. And so the only one that applies there is the carbon dioxide. And then a gas that exists as single atoms, that is your helium. It does not bond with anything else. It's there on its own. Nitrogen does not count because it's N2. It goes about in pairs, and we say it's diatomic. The atmosphere contains molecular substances. Which 2 boxes or which 2 properties are correct? 1, they do not conduct electricity. Okay, molecular substances do not conduct electricity because they have no ions that can move and they have no free electrons. The other one is that they have low melting points. Okay, they do not form crystals at room temperature, okay, because they're a gas at room temperature. They all have boiling points above room temperature is incorrect. They're all boiling points are below room temperature, so the low boiling points. And they're not hard or strong because they are gases, okay, they're molecular substances. The atoms in a hydrogen molecule are held together by a covalent bond, which are true. So for these, we'll go through and explain why they are or are not true. The nuclei of 2 atoms are attracted together. So that's incorrect because the nucleus is positive, so 2 positive things are not going to attract each other. Electrons are attracted together to form a bond. Well, that's also incorrect because electrons are negative and so they will not attract one another, they will repel one another. The nuclei of the two atoms repel each other. Now that one is correct because they're both positive. The nucleus of each atom attracts the shared electrons. That's also true because you have a positive nucleus and negative electrons, and they will attract one another. Finally, the electrons repel the nuclei away from each other. That's simply incorrect. They actually form a bond in between them. This was one of those of the three big equations that you're expected to know. Okay, so we have a carbonate and an acid. So carbonate plus acid goes to salt, water, and CO2, and carbon dioxide. So the salt that we got here, you can see it below, we have calcium and chlorine together, so that's calcium chloride. Our symbols then, calcium carbonate, well calcium is Ca, and carbonate is CO3. Okay, so we have Ca2 plus, CO3 2 minus, gives me CaCO3. Plus 2HCl goes to CaCl2, which is calcium chloride. And then I said we had water, which is H2O, and carbon dioxide, which is CO2. Okay, you must learn those general equations. Acid plus metal goes to salt plus hydrogen, acid plus alkali, salt plus water, and acid plus a carbonate, salt and water and carbon dioxide. Then we had another 6-mark question, the last 6-mark question, and you're being asked to show that the more concentrated the acid, the faster the reaction. How would you show that in this with this setup? So what was going to happen here is that we have this solid calcium carbonate, you added acid, and you created carbon dioxide. So that carbon dioxide went into the gas syringe and basically pushed the end of the gas syringe so you could measure what volume was formed. So how could Alex use the equipment and the results to show that the more concentrated the acid, the faster the reaction? So the first part was actually explaining what you would do. So you would take each of the 3 different acids, you would use the same amount of acid or the same volume of acid, add it to the same mass of calcium carbonate, and you would time how long it takes to get a particular volume of carbon dioxide gas. Alternatively, you could have said that you had 30 seconds and you were going to measure the volume of gas produced in that 30 seconds in a particular period of time. Because the gas that was formed, don't forget, is going to come up and it's going to push this across, so you can actually measure how much is formed. The second part of the question was for sense. That would have got you 4 marks. You have to say that you need the same volume of acid, the same mass of the calcium carbonate, and so on. That would have got you 4 marks. And for the last 2 marks, you then had to say that having a higher concentration would result in more gas being formed at a particular period of time, and so that is a faster reaction. Look at the mark scheme for this. You could have gone several different ways for answering this question. Check out the mark scheme to see which way you should have described your answer. And then our final question then. The results of the experiments confirm that the reaction is faster with more concentrated acid. Why does that happen? And the answers here were at a higher concentrations, there are more particles in the same volume. Okay, so yes, that is absolutely correct. If you have more concentrated, you have more particles in the same space. And then finally, the collision rate increases when particles are closer together. If they're closer together, they are more likely to collide. Okay, so you will get an increase in your collision rate. From this point, please go through the exam question, make sure all the exam questions, make sure that you understand where you've gone wrong. Go back over this video to the parts that you were not too sure about. And if you need further help, ask me or your chemistry teacher. Okay, bye.